Good evening everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. I hope you all are well. Today I am going to discuss about the numerical questions of a chapter Laws of Motion. If you want regular videos and all, you can download our app. A link of our app is given below. You can easily access our courses. So I welcome you all in a Sapience Education once again, and if you want to know more about our education institute, you can visit our website www.sapienceeducation.com. Now, question 4.6, a constant force acting on a body. See, question, try to see what question is asking. Okay, a constant force acting on a body of a mass 3 kg changes its speed from 2 meter per second to 3.5 meter per second. Let us consider this is a body, right? And it has a mass how much? 3 kg. Okay, and it changes its speed from 2 meter per second to 3.5 meter per second. So let us consider its initial velocity is 2 meter per second and final velocity will be 3.5 meter per second. Okay, now time taken, how much time taken to reach here? So time will be equal to 25 seconds as per the question. Now the direction of the motion of the body remains unchanged. What is the magnitude and the direction of the force? So definitely if you want to find the magnitude of the force, so force can be rate of change of momentum or force can be m acceleration A. Can we write here m into final velocity minus initial velocity by time t. So what is our mass? 3 kg. What is our final velocity? 3.5. What is our initial velocity? 2. What is our time? It's your 25. So this is your 3 into 1.5 divided by 25. So 45 divided by 25 into 10 power minus 1, right? So it will be how much? So this will be 0.18 Newton. Okay, and force will act along the direction of velocity. Force will act along direction of velocity. I hope you have understood, because when you apply a force here, so then as per the question they are telling that direction of the motion is not changing. It means that force is in this direction, velocity is also in this direction. I hope you have understood question number 4.6. Now question number 4.7, a body of a mass 5 kg is acted upon by two perpendicular force. So there is a body, okay, suppose there is a body and a two perpendicular force acts 8 Newton and 6 Newton. Let us consider 8 Newton is acting in this direction and 6 Newton is acting in this direction. And what is the mass of the body? Mass of the body is here 5 kg. Okay, since both are acting perpendicularly, so this is your 90 degree. Give the magnitude and direction of acceleration of the body. So acceleration, for acceleration what we need? For acceleration, A is equal to force by mass. So mass is given, but force, which force I should take? So definitely you should take resultant force. Definitely you should take resultant. This is the resultant force. Okay, how you will find the resultant force? So resultant is equal to root under 6 square as per the formula plus 8 square plus 2 into 6 into 8 into cos how much angle it has 90 degree, so this is a cos 90 degree, so this will be 0 only, so this will be 6 square. The 6 square means 36 plus 64, so this is your root under 100, so this will be 10 meter 10 sorry, it will be 10 Newton, it will be 10 Newton. So resultant force we have got 10 Newton. Now can we find now acceleration? Acceleration is equal to 10 Newton divided by mass is how much? 5. So this will be 2 meter per second square. Now what is the direction of the acceleration? So definitely if resultant is acting in this direction, so direction of acceleration will be in the direction of acceleration. So here we can write here that direction of acceleration is in the direction of force. Direction of force. So that is angle, this is, suppose this is your theta, this is your theta, so tan theta is equal to perpendicular force by base force, that is equal to 6 by 8, so theta will be equal to tan inverse 6 by 8. So this is the direction of the acceleration. I hope you all have understood now. Now we will go for a question number 4.8. Now question number 4.8 solution. At first you should read the question. The driver is a driver of a three-wheeler moving with the speed of 36 km per hour. Sees a child standing in the middle of the road and brings his vehicle to a rest in 4 seconds. Just to save the time, in a time to save the child. What is the average retarding force on a vehicle, and the mass of the three-wheeler is 400 and the mass of the driver is 65. So let us consider this is a three-wheeler. This is a three-wheeler vehicle, okay? It has mass, how much? Mass should be including driver also. We should consider 400 plus 65. So this is a 465 kg, right? Now its initial velocity is how much? U is your 36 km per hour. Can we convert it in a meter per second? So 36 into 5 by 18 meter per second. So this will be 10 meter per second. Suddenly when driver saws a child, so it will reach here and it will break, stop its three-wheeler. So final velocity will be 0, because if velocity will not 0, then accident will happen. That's why velocity before the child came near by it should be 0. Okay, and this happened, how much time taken? For this duration, time within 4 seconds he has stopped. Okay, now what is the average retarding force on the vehicle? So retarding force means what? The force will act in which direction? Definitely in opposite direction, because brake is acting here in opposite direction. So what will be the retarding force? So force will be equal to mass into acceleration. Since acceleration is negative acceleration, so mass is your 465. Acceleration means what? Final velocity minus initial velocity by time t. So this will be 465 into final velocity is how much? 0. Initial velocity is your 10 divided by time is how much? 4. So this will be 465 0 divided by 4. So this will be 4 1 ja 4, 4 1 ja 4, 2, 4 6 ja 24, 4 2 ja 10, 4 2 ja 8, 4 5 ja 10. So this will be 1162.5 Newton. So exactly this force here, brake is applying this much force. This much amount of force is brake is applying. Okay. Okay, I hope you have understood. So this is the retarding force. So here it is your negative because force is acting just opposite of the direction of motion. Force is negative. Force is negative because force is acting opposite of the direction of motion. Okay, I hope you all have understood now. Now, yeah, it's a question number 4.9. A rocket with the lift of mass is how much? 20,000 kg. Is blasted upward with the initial acceleration of 5 meter per second square. Calculate the initial thrust force of the blast. What is the situation here? We should try to understand. So suppose this is your rocket, this is a rocket, okay, it's a ISRO rocket, okay. Now its mass of the rocket is 20,000 kg, is blasted upward with the initial acceleration of 5 meter per second square. So this will be 5 meter per second square. Okay. Now we supposed to find initial thrust force of the blast. Suppose this missile, this rocket suddenly escapes the gas. So gas will come out. So gas will apply the force. So force by gas to the rocket is known as thrust force. Okay. Now if I will draw the free body diagram, then which type of force is acting here? First of all, mass mg is acting downward. Okay. Gas is applying a thrust force, F thrust. As acceleration is upward, so definitely there will be a pseudo force mass into acceleration as per the concept of free body diagram. So all three forces are acting on this rocket. So for an can we equate this force? So if we equate, so this will be F thrust plus F thrust is equal to mg plus ma. Since mass of the rocket is 20,000 kg into g is your 10 plus acceleration is 5. So this will be 15. 15 into 2, this will be 30. 1, 2, 3, 4. So such a F thrust. This is the F thrust. This is the force due to which this is the force of 3 lakh Newton thrust force is applied on the rocket, so that rocket escapes and go with the acceleration of 5 meter per second square. I hope you all have understood. Now I will discuss about question number 4.8. Okay, a body of a mass 0.4 kg moving initially with a constant speed of 10 meter per second to the north. So let us consider north, south, east, west. So this is your east, this is your west, this is your north, this is your south. So body starts from where? See, a body of mass of the body is how much? 0.4 kg. Mass of the body is 0.4 kg. Moving initially with the constant speed. So its initial velocity is 10 meter per second to the north direction. So a body is moving in the north direction, that is in upward direction, subjected to a constant force of 8 Newton, but force toward the south. So this is the direction of force, this is the direction of velocity u. So u is in upward direction, force applies is in downward direction. So here retardation will happen. Retardation will happen. Okay, that is negative of acceleration. So force, constant force of directed towards south for 30 seconds. How much time? For how much time it is acting? It is acting for 30 seconds. It is acting for 30 seconds. Okay. Take the instant of the force is applied to be t equal to 0. The position of the body at the time to be x equal to 0. So if I will tell this is your x axis and this is your y axis, so at x equal to 0, time is equal to also 0, and at that time force start being applied. Earlier it was going in this direction with the speed of 10 meter per second, but at the time force is applied for a 30 second in opposite direction. So what will happen to the object? So definitely if object is going upward and if a force is acting in downward direction, so object will retard, and at some time it will move in a opposite direction, because constantly if it is going with a 10 meter per second, so certainly one time will come that it will become a 0 meter per second, and after that it will start increasing. Okay, for till 30 second only. Okay, now take the instant force is applied to be itna. Okay, predict at the position t is equal to minus 5 second. So we need to find predict its position. So first case, t is equal to minus 5 second. So let us consider this is a graph. At t equal to 0, its position was 0. Okay, so at t equal to minus 5 second, so how much it will be? So at t is equal to minus 5 second, what will be the position? So position is equal to s equal to ut minus ut plus half at square. As before t is equal to 0, as time less than 0, no acceleration are there, so it will be 0, and initially its velocity was 10 meter per second, into time is minus 5 plus 1 by 2 into acceleration for less than time equal to 0, acceleration is 0 into t, so this is your 0. So finally how much distance it came? Distance is equal to minus 50 meter. It means that in minus 5 second its position is minus 50 only. Okay, now case 2. Now I am talking about case 2. Okay, that's a case 2. It's a second case. What is the second case? Second case, it's in as a question they are telling. In second case, the question they are telling, at 25 second what will be the position? So at 25 second, so we need to find the position. Okay, so let us consider time equal to 25 seconds. So what will be the position? Now s is equal to ut minus 1 by 2 at square. Since t is greater than 0, so at that time force is acting. So if force is acting, so acceleration is acting. Acceleration is there. So what is the acceleration? How much acceleration here it is? So how you will find the acceleration? Mass is given, force is given. So how you will find acceleration? So acceleration will be equal to force by mass. Force is your 8 Newton, it is given. Mass is how much? Mass is your 0.4. Okay, mass is how much? Mass is 0.4 kg. So how much acceleration it will come? So it will come, so this will be 80 by 4, so this will be 20 meter per second square. So if acceleration is 20 meter per second square, so you can find initial velocity was 10 meter per second into time is how much? 25 minus 1 by 2. Why I am taking minus? Because its force is acting in negative direction, so acceleration will be negative. Acceleration will be minus 20 meter per second square. So if I will use acceleration, so acceleration is negative retardation, that is minus 20 into 25 whole square. So how much answer it will come? This is a 250 minus 210 20 625 minus 6250. So this will be ultimately minus 6000 meter. So if I will plot the graph, so it is, suppose this is your position 0, so our objects or body's position will be minus 6000 meter downward direction. So this is the case. Now case third, when a time is equal to 100 second. So what will be the answer? How you will find time is equal to 100 second? If time is equal to 100 second, show what how you will find a solution. See, let us consider time is equal to 100 second. Okay, as we know that for 30 second force is acting, so acceleration will be 20 meter per second square. But for next 70 second, no force is acting, so acceleration will be 0. So at 70 second, for a 70 second, what will be the distance covered? So for first of all, we should consider for first 30 second. So for first 30 second, s equal to ut plus 1 by 2 at square. So this is a 10 into time is 30 plus 1 by 2 into acceleration is 20 meter per second square. 20 meter per second square. So I will have to give a value only. Okay, 20 meter per second square into time is 30 square. So this will be 300 plus 2 times 20. So 3 is 9, 900, 9000 plus this. But since acceleration is in negative, so no need to take here positive, so we need to take here negative, because acceleration is negative, it's a retarding motion, so we have to take a negative only. Okay, so negative, if I will take a negative, so how much it is? Negative like this. So this is 9000 minus, so this is minus 8700 meter. Okay, But now the answer is not complete. Why? Because it is for first 30 second, and for next 70 second distance is how much? So we don't know. So at 30 second, what is the velocity? At 30 second, velocity will be, so velocity will be v is equal to u plus at. So initial velocity was 10. Initial velocity was 10, and it's not working. Okay, no issue. Okay. Okay, initial velocity was 10 minus 20 acceleration into time 10. So this is how much? Time is 30 second, right? So we need to put here 30 only. Okay, it's a 30. It's a 30. So 10 minus v equal to u plus 80. 10 minus 600. So this is your 590 negative velocity. V is equal to minus meter per second. Okay. Now we have got v is equal to, so with this velocity it will move, with this velocity it will move. Okay, so for next 70 seconds, so s is equal to v into t, so this will be minus 590 into time is what, 70. So this will be minus 7 9 ja 3 63 6 7 5 ja 35 plus 6 41. So this is your 441,300 and this is your 8700. So total distance or displacement, we can say displacement will be equal to minus 8700 minus 41300. So how much it is? 41300 8700. So minus both are, so we should add 7 3 10 0 5 minus 50,000. Okay, its position will be minus 50,000. Okay, I hope you all have understood this. So you have got how much? I have got minus 50 kilometer. So if I will draw the diagram, so this is a 0. So up to some distance, this will be minus 50 kilometer. Okay. So this is what it is all about. I hope you all have understood this. I hope I will make another videos for next section. Thank you everyone. For regular updates, please be connected and subscribe our channel. Thank you.